Now let's see some examples on refraction at plane surfaces, especially for image formation. We have a glass slab, its thickness is T. Surrounding medium is air, both sides. There is an object in air under the glass slab, and here lies an observer. Now the question is, what is the shift in the actual position of object which this observer finds? That is, if you remove the glass slab, then observer will find that object is placed right here because they both are in air. But when you place the glass slab, due to refraction, this object will not be formed at this position. It will get shifted, and our aim is to find the shift. So write down the question first. Find out shift in the position of an object when a glass slab of thickness T is introduced between observer and object. The first thing, pause the video. There are two surfaces. First, light rays will move from air into glass, then from glass to air. That means you have to use that image formula, Hi upon Ho equals to mu I upon mu O twice. Hi upon Ho equals to mu I upon mu O. You need to use this formula twice. Once from air to glass and then from glass to air. What basically is happening, this is an object which is in air. First you need to form its image with the help of air to glass refraction. That image will work as an object for glass to air refraction. Give it a try. It's not that difficult. You can answer it. And if you cannot, come back and see the solution. So, first ray is this. This ray moves along the normal. Incident ray, refracted ray. Let's not take it out. Right now, let's say we have another observer. Let's call it observer dash. Let's find out things for this observer dash. So this is the incident ray, this is the refracted ray, which will be observed by this observer dash. Then that's your second ray. At this position, you will draw the normal. That's the normal. Then, since you are moving from rare to denser, this light ray will deviate towards the normal. It deviates towards the normal. Now, we have got two refracted rays. Intersection of these two refracted rays will give us image position for this observer dash. And how do you do that? You will produce this refracted ray backwards like this. And then do this. This is your object. This is the image. Let's call it I dash as it is seen by observer dash. Suppose this height or distance from this interface of air to glass is h. Let's call it h. Then let's find out this distance h dash, which is seen by the observer. This observer is not going to see object which is located at this point. That's your object O. This is your image. This observer is going to see this ray and this ray. These two rays, they meet at I dash. And therefore, this observer finds that image is at a distance of h dash from this interface of air and glass. Now, aim is to find h dash. What is h dash? Hi. What is ho? H. What is the medium of I dash? Medium of image is the medium of observer. That's the observer. Observer dash is in which medium? Glass. And therefore, image formation takes place in glass. Object is in what? Air. This incident ray and this incident ray, they both are in air. And therefore, mu object is what? Mu air. Now, refractive index of glass is simply mu for us, and refractive index of air with respect to air is nothing but 1. From this, we have obtained h dash, which is coming h times mu. You can also see that h dash is coming greater than what? H, which you can also see in this figure. As this incident ray deflects towards normal, it is going to meet somewhere at this position, which is definitely greater than what? H. Now, once you have got I dash, this I dash, remember, is in glass. Is in glass. In the medium of observer dash. Now let's talk about our original observer. When you talk about this observer, these two are what? Incident rays. If these are incident rays, then let's find out their refractions. This ray will move straight towards the observer because it's moving along the normal. This second ray, you will draw a normal at this place. That's a normal. Now, this ray is moving from glass into air, from denser into what? Rarer. Denser into rarer, that means it will deflect away from the normal. Now, always remember, all these angles are what? Very, very small. Just so that you can see all things clearly, we have taken such a large figure. Otherwise, this ray and this ray, they both will be collected by the eyes of this observer. Now, this and this, these two rays, they meet somewhere here. This is the final image which forms. This image is what observer sees of your initial object. Now, this ray and this ray, they are in which medium? Air. And therefore their intersection will also take place in which medium? Air. Which means you already have information of I. This I is in air. So if you apply same formula again, Hi upon Ho equals to mu I upon mu O. Now let's decide right hand side first. If you look at the image part, this is your image which is in air, and therefore mu image, it becomes mu air. Immediately you know that mu object should become what? Mu glass. But let's verify it. This and this, these two are incident rays. If these are incident rays, for these two refracted rays, remember, since these are incident rays, they lie in which medium? Glass, and therefore their intersection will take place in glass. Which means mu object is what? Mu glass. Now, Hi and Ho. If you are interested in this glass to air refraction, then all these distances should be taken from this interface. From this interface, this position is Hi. Position Hi from this interface of your final image. So let's keep Hi as Hi only, divided by Ho. What is object? This interface, this refraction, you know that I dash is what? Object. And you need to take its position from this interface. That means you need this much. From here to here, I dash. What is this? This part is already what? T, and this much is what? H dash. Look at this level. So the whole thing is what? H dash plus what? T. So that's your H dash plus T. What is this? This is the actual position of your object from the interface. Now let's put this distance over here, and you get H dash plus T. That's your Ho for glass to air refraction. Now we have already found the value of H dash. H dash for us is what? H multiplied by mu. Let's put this value of H dash in this equation, and you get Hi divided by H dash, which is H multiplied by mu plus T, and on the right hand side mu air is 1 and mu glass is what? Mu. That gives us Hi as what? H plus T divided by mu. Cross multiply this over here, mu and mu cancelled, and you got H plus T upon mu. What we have found? We have found position of final image of this object with respect to this interface. But question says we need what? Shift. Instead of observing object at this location, this observer observes it at this position, and therefore we need to find what? We need to find this shift from O to I. Our aim is to find OI, this separation. So when you say shift, this shift is nothing but OI, or separation between this O and this final image I. How do you find it? You already have Hi. You just need to find distance of object, which is also there. What is the original distance of object from this interface? T plus what? H. So OI becomes what? OI becomes H plus T, H plus T minus what? Minus what? HI. HI, which is H plus T minus of HI, which is minus of H minus of T upon mu. Finally, H and H cancelled and you get T common, 1 minus 1 upon mu. That's what we are looking for in this question, which is what? Shift. Shift as you introduce this slab of thickness T. Now let's verify the answer, whether the answer is correct or not. We can also verify it. If you say that you have introduced, instead of a glass slab, just assume that you have introduced a slab of air, which means nothing special. Air, air, air. If you insert a slab of air, that means there should not be any shift, which means what is refractive index of air with respect to air? 1, which gives you 1 minus 1, that is what? 0, and therefore shift will be 0. This part is an important result for any type of examination, board, NEET or JEE. Remember one more thing, if they frame this question instead of air and glass, if they give you water, glass, water, water, glass, water, then I hope you know you just need to replace that mu with what? Refractive index of glass with respect to water. Right now this mu is refractive index of glass with respect to air, of glass with respect to air, but situation is if like this, water, glass, water, then you must go for refractive index of glass with respect to water, which you already know is mu G divided by mu W. Note down this much. Now look at the second method for the shift which we have obtained. We've already done these things that suppose you have a coin at this position in water and an observer looks at it from air. Then this observer finds that coin is basically not at this position, is in fact this position, which is the image of coin. Let's call it coin dash. If this thing is H, then I hope you remember that this H dash for the coin dash as seen by observer is simply H, either you multiply or you divide. You can remember the trick. But you can see that H dash is what? Less than H, and therefore you must divide it by mu. This mu is refractive index of water with respect to air, or basically refractive index of denser medium with respect to rarer medium. This is what you must know before we go for the second method. You can also use this formula if you wish. Coin is object. This object is in water, and therefore mu object is what? Mu water. Image of this coin, which is coin dash, will be seen by this observer, who is in air. Image formation takes place in the medium of observer, and therefore refractive index is what? 1. Hi is H dash, HO is H. They both are taken from this interface, and we have already done this thing, and therefore you can see H dash is coming simply what? H upon mu. So second trick, you must remember this part. Now, this is your observer, that's the object. This thickness is T of this glass slab, which is placed in air. Now let's ask this observer to replace this whole glass slab. How does he remove this glass slab? You can say that for this observer, this lower surface of glass slab, which is at a depth of T, will appear right here. This lower surface for him is not at this location, but is at this location. Look here, for this observer, coin or bottom of this water slab is not at this location, but is in fact at this location. So he doesn't see bottom of the beaker at this position. Instead, he finds the bottom of the beaker right here. And this is something which you have observed yourself. Put some water in a container and then look at it along normal. You will find that bottom of the beaker is slightly up. That's what is happening. He finds that bottom of the glass slab is not here, but is up here. This is image of the bottom of glass slab. Remember this. This is the image of bottom of the glass slab, and that's your bottom of the glass slab. So now you know that this is what? T divided by mu. T divided by mu. ज़्यादातर लोगों को शिफ्ट दिखना शुरू हो गया होगा in just one line. He finds that bottom of glass slab is here. What is the shift in the bottom of glass slab? From this position to this position, what is the shift? This much is T. This is T by mu. This shift is what? T minus T by mu. Now how come this shift is same as this shift? Let's just prove this point. The whole thing is done. What is the medium of this blue line? Or what is the medium of image of the bottom of glass slab? Now who is basically looking at this part? Who can see this blue line? This observer. What is the medium of observer? Air. And therefore this blue boundary which you see, this blue boundary is in what? Air. Now look. Top of glass slab is in air. bottom of glass slab is also in what? Air. For this observer. And if you remember, I had told you that an observer always finds that everything is in his medium only. For him, there is no glass slab. What he sees is something whose thickness is what? This much, T by mu. And therefore, once you place a glass slab of thickness T, he replaces this glass slab with an air slab of thickness T by mu. So, what you are basically doing, you are replacing T with T by mu, thereby producing a shift of T minus T by mu. Nothing special happens with this object. Why? Because this thing is already in air. So, everything is happening around here with the glass slab. Something of thickness T, a glass slab of thickness T, has been replaced with an air slab of thickness T by mu. Therefore, for him, a shift of T minus T by mu is present. You could answer this question in just one line. This is technically just one line. That's the beauty of these concepts. What type of concepts? If you can remember a few things, that an observer finds that everything is in his medium only. For example, when you are in air and let's say your friend makes a dive and enters into swimming pool, he is inside. Now, when you look at him, you do not see him in water. For you, he is in air because you yourself are in what? Air. Now, if you ask him and if he looks at you outside from the water, then for him there is no air. Around him, since it's only water, he will say that you are also in what? Water. But basically he sees image of yours. That's what is happening here. For this observer, remember once again, there is no glass slab. Since he finds no glass slab, he says whatever is present right here has a thickness of T by mu. But you know that this is T, and therefore you tell him that a shift of T minus T by mu will be present when he looks at this object. If you ask him, if you don't tell him that it's a glass slab, here lies an object, if you ask him that find out shift, he will say there is no shift. There is no shift. It's like if you see a coin, in this water tank, and if somebody asks you what is the shift, then for you there is no shift. Whatever you see is not the object, is what? Image. So you have no idea of water. If this water is neat and clean and no reflection takes place at the top, which always happens, and therefore you already know that something is present inside. But suppose this water is neat and clean and there are no disturbances and all, there are no vibrations and all, and there are no reflections. If you look at the coin, then you will find this coin dash, which is the image, and for you there is no water. You will simply say it's only air inside. It's only air inside. When somebody shakes this beaker, that will create disturbances and you will get to know, okay, there was something inside, which is what? Water. Otherwise, if it's quite still, it doesn't move, doesn't vibrate at all, then there is no way you can tell whether water is present or not. We'll see a question based on this later on, but Note down this whole thing. Just write down a few statements also before that. Since an observer, write down the statement, since an observer always finds, that all the things around him are present in his medium only. In his medium only. Observer in the given question finds that bottom of the beaker, bottom of the glass slab is not in glass but is in air. Image of the bottom of glass slab which is in air. Also mention this. This thing is in air. I've already told you this part. So this observer finds that this bottom is in air, and therefore we can say that as if somebody has replaced glass of thickness T, glass slab of thickness T with an air slab of thickness T by mu. With an air slab of thickness T by mu. Thereby producing a shift of T minus T by mu. T minus T by mu. Hopefully पूरा मैसेज क्लियर हो गया होगा. Note down this.